9 was where we left off. We've got 3 parts here to this fractional exponent. I need to know what those 3 parts mean. So, what root are we dealing with? The 8th root. What power are we dealing with? The 9th power. Okay? And then what about the negative one? That's the flip, right? So that creates this situation right here. That is a full credit answer. But I believe when we did this question in class, there was also an extra credit version. What was that extra credit version? What can you do? Find it. Wait. I thought you were looking for it. Yeah?
How is it positive?
The negative is in the exponent, which causes the base to flip over. Okay? It is not a negative number. It's a negative exponent.
So normally the root would be on top?
No, the root is always on the bottom. When we say the flip is occurring, it's not occurring to the exponent. It's occurring to the base. So, for instance, the base is x over 1.
Yeah.
And so when you flip the base, that's why you end up with the x being in the denominator and the 1 being on the top.
So it would be x over 8.
If you didn't have that negative, then the answer would just be the 8th root of x to the 9th.
Yes.
Okay, now, what simplification can you do if you want to try for extra credit?
Can you tell me how we can go into 9?
Can 8 go into 9, yes or no?
Yes.
How many times? Once. With how much left over? With 1 left over. So if you wanted extra credit, you could simplify it, pull out the perfect 8th, and leave the 1 trapped in, the 1x trapped inside of it. Okay, but that's up to you. As long as you understand the root and the power and the flip, I'm good with that. Okay, question 10. Is the radical by itself? Is the radical by itself? You got to take the 3 over, don't you? Okay, so we're going to add the 3 to the other side. So radical 2y plus 5 equals 5. All right, now what? Square both sides. 2y plus 5 equals 25. Solve it. 2 more steps and you're done. 2 more steps. You're finished. Subtract 5. Then what?
Divide by 2.
Divide by 2. Y is 10. Is the radical by itself? Nope, there's 2 things you have to do to get the radical by itself. What are they? Well, that's the second thing. The first thing would be to add 16. The second thing would be divide by 2. So radical, yeah, we do get 16 again. Good. What do we do to both sides? Square it. We do not get 4. What do we get? What's 16 times 16? What do you got, Mr. Anderson? 256. Okay, good. 256. Glad we got a few people with that answer. Okay, this is probably your most difficult question on this particular test. Is the radical by itself? Yes or no? No, so we subtract 3. Now the radical's by itself. What are you going to do to both sides? Okay. So the part that I'm worried about is squaring x minus 3. What is x minus 3 times x minus 3? Because that's what squaring means. You multiply times itself. A lot of you say things like x squared plus 9, and that's where you make a mistake. What did you forget? Okay, you did the first and you did the last, but you forgot about the middle stuff, right? So what is it? It's a minus 6x, right? Because you get a minus 3x and a minus 3x, which adds up to minus 6x. All right? And of course, on the other side, the easy stuff where the radical and the square root cancel out. What am I suggesting to you with these two green arrows? You got to put them on the other side. Now I want you to solve it. See what you need to do to solve the rest of it. Did you factor it? If so, what did you factor it into? 8 and 3, right? Right? X minus 3, x minus 8, right? Doesn't matter in what order you put them in, as long as you have that. So now solve it. 3 and 8, right? 3 would cause it to turn into 0, and so would 8. So those are both good answers.
It's just that easy.
Okay. Is the radical by itself? No, we got two different radicals. So we're going to put one of those radicals on the other side. I'm going to put that one on the other side. So now I've got radical 9y plus 7 equals radical 8y plus 10. Now what? Square both sides, right? Because the radical by itself. Which this is kind of nice because the radicals are all going to disappear. So solve. Good. Okay. When will we be taking the chapter 7 and 8 portions of the final exam? On the actual final exam period, right? For you guys, that will be? Well, if you want to come Friday, good luck with that. You know, I'm pretty sure most of the seniors won't be here on Friday of next week. But Thursday, yeah, I'd say Thursday would be the day for us, right? Because 4th and 7th are Thursday.
Is it just those two?
I know. Yeah, that's it. Just those two, because you won't see any of your other classes.
What are you going to do during this period?
Yeah, tomorrow. What are you gonna do?
What am I going to do? I'm going to be grading tests.
Good luck.
Yeah.
I'm going to be finishing your chapter 10 tests will all be graded tomorrow, by tomorrow.
Yeah, you should come to city activity.
I got too much work to do, man. You guys enjoy it.
We get breakfast.
I should put a comedy routine together, you know?
Free breakfast?
Yeah.
Yeah, I don't have any lunch.
Yeah, a free breakfast at like 10:30 in the morning.
Hey, man. It's a
It's a
I know
brunch.
you'll be hungry.
It's free?
I know.
Dude, I'm not
Yep.
I'm there. Let's go.
Okay, so several of you saw that you push the 8y to the other side and push the 7 to the other side and you get y equals 3. You are correct. Okay?
You going now?
Okay, so that's the chapter 7.
That's the end of chapter 7.
That's the end of the chapter. Okay. If it's increasing by 7%, what's the multiplier?
1.07.
1.07. I'm going to switch this. Yeah, that's good. Well, that's probably just a touch too much. Go to 3. There we go. Okay, what is the amount of money that we're starting with? 370 billion. Folks, we're not going to write all those zeros. We know that our answer is going to be in billions. Okay? Billions with a T. 13 would be the exponent. Let's see. Do we agree with that? We're starting in 2006 and we're ending in 2019. I believe that would be 13. Right? So, use your calculator, type it in. Sure. Let me grab my other one. Trade your phone.
Patrick's in my wallet. Because my mom texted me about me picking my puppy up.
Okay, well, make sure you don't walk out without this. Otherwise, it's going to be a difficult conversation for you.
Oh, you can't pick up your puppy.
You get that warning ticket, right?
Would I actually get a warning ticket for that?
If you didn't have your license, they would definitely be questioning you a little bit more. I'm not sure what they would do. Okay, so what did we end up with? 892 or 891.6, something like that. Now, as we talked about before, rounding is not the issue. Show your work. I need to see that you think that the multiplier is 1.07. You're raising it to the 13th power and multiplying by 370. I can forgive rounding issues, unless of course you're going to make it 900 or 1. If you went to $1 trillion because you said you would round to the nearest trillion, then I would have a problem with that. But show your work. Okay, this is exponential growth. Exponential growth reminds me of geometric sequences. What's the multiplier of this geometric sequence? Yes, folks, I understand this is not chapter 10 where we talked about geometric sequences. But it's the same type of idea. What's the multiplier? 3. Is that growth or decay? That's growth. Well, no, because it's not. If it was less than 1, then we would have decay. They definitely will not be negative. We're not going to throw negative multipliers at you in this type of situation. What is 3 to the 0? What do you get when you plug in a 0? 1. What do you get when you plug in a 1?
3.
And what do you get when you plug in a 2? So to go forward, you're multiplying by 3. What will you do to go backwards? Divide by 3. Right? 1 divided by 3. And to go backwards again, you would divide by 3 again, giving you 1 over 9. It's the same idea that we had with our sequences. Which, now, I know that A and B are wrong, folks. I know that A and B are completely wrong. What kind of graphs are A and B? They're not exponential decay, folks. They are definitely not exponential growth. Starts with an L. They're not linear, folks. Lines are straight. Starts with an L. It was in this chapter. We did it a bunch. Logarithms. Thank you very much. These are log graphs. Whoa, that's a bad looking G. Okay, so these are definitely not the ones we were looking for. Which one of those, C or D, looks like it's growing by 3? D is growing, but it's not growing enough. Okay, it's growing a lot faster.
It's C.
I was thinking the same thing.
What are we thinking? What?
These are not the-
Oh no, yeah, I think that I use that all the time. So
These are not the graphs.
yes. Okay, so what is this? Exponential growth or decay? Definitely decay, right? Because the growth factor is smaller than 1. Okay, how do we find every y-intercept in the universe? We plug in an x value of 0, not 1. If you want to find a y-intercept, you want it to be on the y-axis. What happens? What is 4 times 0.66 to the 0 power? It is 4. Nicely done. That takes care of 8.1. Moving on to 8.2. Okay. Is this exponential growth or decay? 1 over 11. That is decay, right? And I don't really see an A, B, C, or D, so which one do you mean by C when you said that?
Yes.
Ha ha ha. Oh, which one of those looks like exponential decay? Let's use words like upper, lower, left, right.
Upper left.
Upper left? Nope, that is definitely not decay.
It's not on the same graph, sir.
Ah, nope, it would be the northeast there. Okay, I know that it didn't show up on some of your pages. I don't know why. Some of you actually don't even have a picture. The printed versions, I'm not sure why they didn't show up. It's kind of weird. Yes, very awkward. Please just draw a picture in that looks like this one. Okay? That seems too hard? Okay. All right. Do we have exponential growth or decay in this question? That is definitely growth. It has been shifted which way? Up, down, left, or right? It has been moved down 5 units, right? We've got this. What do we call that cool line that it gets closer and closer and closer and closer to but never touches?
Sounds inappropriate.
Yes, it sounds inappropriate. The asymptote, right? Lots of cool jokes from that. Okay, now, domain. That's where we push all of the values onto the x-axis. Everything gets pushed onto the x-axis forever and ever and ever and ever and ever and ever.
Greater than or equal to.
How much of the x-axis would get covered?
Oh, wait.
All of it?
Range.
Yeah, you're thinking range. So I'll take this answer, all reals. I'll take the all real number sign. I'll even take negative infinity to infinity if you want to do it that way. It doesn't really matter.
Range would be
Now, range would be more interesting than that one.
Y is greater than or equal to no.
Is my answer wrong?
Yes.
What is wrong with my answer? Yeah, good catch. Good catch. Can't be equal to. Yeah, that equal to. I'm glad. I knew you were catching it, Mr. Brown. As soon as I wrote it, I was like, he's catching this. This is good. You cannot touch the asymptote. MC Hammer guaranteed us that. Exactly. Okay. We got exponential decay or growth. Which one is this?
Decay.
This is decay, and it's been shifted which way?
Upward.
Down 1.
It's been a long
Okay.
time.
Yes. How would this be different if I wrote 1/4 to the x plus 1 or x minus 1 like that? How would that graph be different? Which way would this one move? When it's up there in the top, what's this one going to do? That's going right 1. All right, but we're not in that situation, folks. We're in the down 1 situation. So we got decay and down 1, which graph? There's only one graph that even looks like exponential decay. What is it? D, thank you very much. Remember, it has to start high and go down to the right as time goes on. But you'll notice it went across the x-axis because it's been shifted down 1 unit. Okay, that takes care of that section. 8.3. They gave me an equation. Okay.
Make sure I printed you all.
Do you have 8.4, 8.5, 8.6? Oh my goodness!
Which ones do you
Did
not
you
have?
just not get them off the printer?
Yeah, you probably just didn't grab one.
Yeah. You know what? You're gonna go down there, and it's gonna be there, and then there's gonna be a duplicate.
I even waited.
Sure. Yes, I know, Mr. Albert. I know. Okay, so started in 1994. We're going to 2008. How many years? You'll catch up. More than 12. 14, right? So I would really need to see you typing in or writing down that you're plugging in 14. And then, of course, we're going to go over to the handy-dandy machine and type it in. 409.3, 409 if you want to go to the nearest. Sounds good to me. Let's do 6 more before he gets back. Okay. What does it mean compounded annually? Which one of those formulas am I going to be using? Ran out of paper.
That's why.
So, which one of these formulas should we be using? Is it the one on the left or the one on the right? The one on the left is correct. Okay, now, annually means the end value is what? 1 time a year. 1 time a year. Monthly would be 12, quarterly would be 4, daily would be 365. You just think, how many times a year are they giving me interest? Try not to distract people. Okay, so the end value is a 1 in both cases. Do we know how many years? You want to fill me in? 7. Do we know what to put in for the interest rate?
1.08.
Okay, now I'm going to put 0.08 in for R. Now, I do realize that you are correct, that when that value of n is a 1, it really makes the parentheses turn into 1.08. If that was some other number in that denominator, it would not be that easy, and you would need to use your calculator to type it in. Any idea what goes in front?
12,000.
Your starting value of 12,000. Okay, right? So really, this simplifies down to something nice like this. What do you get on your machine?
Big numbers. Wait, what'd you get for the first?
That's a 7, yes. I'm just waiting. I'm just waiting until you guys. Where are we going to land? Which one? It is D. Thank you very much.
You really had to go around.
Hey, well, I was waiting, man. You guys are taking your sweet time. Type on a machine. It's me wandering around waiting for you to figure it out. Okay, now. This next one says it's compounded continuously. All right, so which of the 2 formulas in the above question would I be? The PERT formula question, right. Compounded continuously. Yeah, that would be a great idea.
Oh my God.
What?
Spent a whole year listening to that thing, man. That is ridiculous.
2000.
Okay, so 2,000 does go in front. For the 4 years goes in there. What are we going to put in there for the interest rate of 5.5%? Should I put a 5.5 in there? Yeah, that would be a bad idea. 0.055. Yep. There is no, you're not putting a 1 in there, folks. The 1 is already absorbed into the letter E. Now, I've had several people asking today, where on my calculator is the E button? Look for probably going to look for an LN button.
It's right above it.
It's right above it, e to the x. All right, so type this in your calculator, and let's see if you can all get the same value.
Did you get 2,492?
2,492.15?
3, yeah.
I believe you're correct. Nicely done.
Shut up.
Wait, was that
Be
recorded?
careful, Nick. I'm gonna throw
Nope.
some fireballs at you. Some fire pop. Whoa!
I hope you know that was recording.
You can't say that.
Logarithm, folks, we need to change it to its log form. Okay. There were, wait a second. Log base, I need to
I
get,
forgot how to do this.
yes, that's kind of why we're reviewing, because I understand. Okay, so we've got a few boxes to fill in. We got a base and an argument and a value on the other side. So what's the base of this?
60.
5, right? The base is 5. Now, give me a one-word synonym for logarithm. A one-word synonym for logarithm. Exponent. Thank you. Oh, yeah. I'll be done with this, too. That's nice. The exponent is 4. Okay, that leaves you with one thing left. 625 as the argument. Okay, there is your logarithm form answer.
So that's as far as you need to go on that.
Well, did you write it as a logarithm?
Yes.
All right, we're done.
Wow.
There's no solving, folks. We have all the values in every single box, so not much you can do there. Okay, now, there's two ways to handle this. It equals x. Sorry, it's bad looking equal sign. Okay, now, we can change it to its exponential form. That's one way to handle it. Okay, what's the base? 2. What's the exponent? X. What's it equal to? 32. Now, if you do it this way, then you're going to have to kind of guess and check until you figure out that 32 is 2 to the 5th, unless you just know that off the top of your head, and you'll tell me that the answer is what? 5. Okay. Now, that's not the only way you can handle this. What other theorem could we use?
It's dummy. Oh yeah, you just do the
Change of base theorem, log of the argument over log of the old base. Type that on a calculator, you should get 5. Now, I don't care which one you do. It's up to you. Pick your favorite one. Now, when you get down to question 3, though, I'm going to recommend one way over the other. Okay, because if you change it into its exponential form, what's it going to look like? Okay, 27 to the x power equals 3. Now, the difficulty about this particular question is you're going to have to change 27 into 3 to the 3rd power. And a lot of you might look at that and go, well, I'm not really, so now I got to look at this exponent and say that 3x equals 1, so the answer is 1/3. Okay, most of you might not do that method on this, but you could do what? Change a base, right? You could say log of the argument over log of the old base. Right? And you will get 0.3 repeating, or 1/3. Show your work. Okay, question 4. I want to write the equation that it is not equal to. So right here, this is not what we're dealing with. Please understand that there's a big difference between them. This is not what we're dealing with. Okay? What's happening if it's x plus 2 in parentheses? That would be left. left 2. So we are not talking about left 2. This is happening on the outside of the logarithm. So this is up 2. Okay? So find a logarithm graph that's been shifted up 2 units. B. B is the only one that even looks like a log graph. All log graphs have the same basic shape. They kind of look like this. And this has been shifted up 2 units. That's it. Any questions on that? All right. Let's do one more graphing one here at least. Inverses. Inverses are reflections across the line y equals x. Do those two look like they are reflections across that line? How about here? Yes. In fact, the green one is 2 to the x, and the purple one is your log function. But they are reflections across that line y equals x that goes through the middle. All right, which way has this one been shifted? Left, right, up, or down?
Left 3.
That is left 3. Now, in your notes, draw a quick basic sketch of a log function that's been moved to the left 3 units. So we've got the asymptote going over here, and we got something like this. From that picture, because we've always said, if you can draw the picture or a basic sketch of the picture, it will help you out a lot when you're trying to answer the domain question. So, push all the points onto the x-axis and tell me how much of the x-axis would be covered.
X is greater than negative.
Is there any equal to on there?
No.
Thank you very much. No. Don't touch the asymptote.
Watch out.
Whatever you do. Oh, yeah, I know.
Okay, I got X on, so.
All right, we'll stop there for today. Now,